Welcome to the Sports Science Hub's guide to everything you need to know about the fundamentals of the cardiovascular system. We will help you understand the anatomy of the heart, how the heart functions, and why blood is so important. Let's get started. The cardiovascular, or CV system, is a one-way transport network. It is made up of the heart, which acts as a pump, blood vessels, which act as a transport network, and blood, the essential bodily fluid. The heart is a hollow muscular pump about the size of a clenched fist. It is involuntarily stimulated to rhythmically contract, which pushes blood throughout the body. Atria are small chambers located in the top of the heart and act like reservoirs. And ventricles are large chambers located in the bottom of the heart. The circulation of blood through the heart starts by entering the right atrium. It travels through the tricuspid valve down into the right ventricle. It then travels through the pulmonary valve to the pulmonary artery, which goes to the lungs. Here, oxygen from the lungs is added to the blood and heads back to the heart via the pulmonary vein. It re-enters the heart into the left atrium, then travels down to the left ventricle through the mitral valve. Finally, the blood travels out of the heart again, through the aorta, and travels to the rest of the body. As long as we are alive, this cycle of blood never stops. Collectively, the right, or pulmonic side of the heart receives blood that is low in oxygen and high in carbon dioxide, or deoxygenated, and then it pumps it to the lungs. And the left, or systemic side of the heart pumps blood that is high in oxygen and low in carbon dioxide, or oxygenated blood, around the body. Unlike skeletal muscle, cardiac muscle has a built-in system that allows the heart to continuously contract without us ever having to think about it. The sinoatrial node, or SA node, is located in the right atrium and acts like a pacemaker to initiate an electrical impulse. The atrioventrical node is located in the wall of the right atrium and receives the electrical impulse from the SA node and directs it to the ventricles, channeling a contraction. This is repeated over and over again and sets the basic rhythm of the heart. This can also be referred to as the intrinsic conduction system. We can see these electrical impulses through an electrocardiography reading. The P wave shows atrial stimulation, or depolarization, from the SA node. The QRS wave shows ventricle stimulation and atrial repolarization, or returning to its resting state. And the T wave that shows ventricle repolarization. If you have ever had blood pressure taken, you may have come across the phrases diastole and systole. Diastole refers to the relaxation phase when the chambers fill, which is the T wave to the QRS wave. And systole refers to the contraction phase when the chambers empty, which is the QRS wave to the T wave. The next component of the CV system is the intricate network of hollow tubes called blood vessels. Like our roads up and down the country, blood vessels transport blood all over the body, varying in sizes and directions. Veins are blood vessels that carry blood towards the heart. Most veins are equipped with valves to prevent blood from flowing in the reverse direction. Venules are small branches of a vein that connect to capillaries. Capillaries are the smallest blood vessel and are only a single cell in diameter. Here is the site for chemical and water exchange between blood and tissues. Arterioles are smaller branches of an artery that connect to capillaries. And arteries are blood vessels that carry blood away from the heart. This impressive network is pretty pointless without something to transport, which in this case is the final component of the CV system: blood. Blood is a unique fluid that surrounds tissue cells throughout the body. It is made up of red blood cells that carry oxygen to tissue cells with the help from hemoglobin, white blood cells that fight infection and protect against disease, platelets that help the blood clot, and plasma, a water substance that holds all of the other cells together and makes up about 55% of blood. Not all blood, however, is equal. Blood viscosity refers to blood thickness. The thicker the blood, the harder it is to pump around the body. We can use a series of functional capacities of the CV system to monitor an individual's health or performance. Heart rate is the rate at which the heart beats. The average resting heart rate for an untrained individual is about 70 to 80 beats per minute. Stroke volume is the quantity of blood ejected with each beat. This can be worked out by taking the end diastolic volume minus the end systolic volume. And cardiac output, which is the amount of blood pumped by the heart in litres per minute. This can be worked out by taking heart rate times stroke volume. When we put this all together, the CV system can provide delivery of oxygen and other nutrients around the body, removal of waste products such as carbon dioxide, maintenance to help regulate body temperature and pH levels, and prevention to help fight infection and maintain an efficient immune system. Thanks for watching. If you liked what you saw, then please help others find our videos and hit the like button below and subscribe to our channel now. You can also find us on Facebook, Twitter and Instagram. Don't forget to also visit our website www.sportsciencehub.com for more videos on everything you need to know about sports science. See you soon.